Now let's look at the big picture.
First of all, there are three main sections of the periodic table. The big sections on the far left and the far right are called the main group elements. They're the most common elements on Earth, like hydrogen, oxygen, nitrogen, and sodium. The main group elements are also called the S block and the P block, and you'll see why in just a minute. Between the main group elements are the transition elements, or D block. They're less common than the main group elements, but still include lots of common metals like copper, gold, and zinc.
Below the table, you might see two more rows of elements. These are called the lanthanides and actinides, or F block.
And they get stuck at the kids' table, so the rest of the table fits on the printed page. If they were included where they should be, they'd be to the left of the transition elements. Uranium and plutonium are the only really famous elements from this series.
Most of the elements on the periodic table are solids when they're in nature. The rest of them are gases, which are grouped together in the upper right corner. And did you know that there are only 3 elements that are found as liquids in nature? They are mercury, bromine, and gallium.
Most of the elements on the table are metals. All of the non-metals are together in the upper right corner, which you might notice is also where all the gas elements are. I mean, can you think of any metal gases? They don't really go together. Where the metals and non-metals meet, there's a stair-step line of elements called metalloids. They have properties of both metals and non-metals.
Half metal, half non-metal, all metalloid!
The periodic table is usually organized into 18 columns or groups and 7 rows or periods. Both are helpful in organizing the elements, but only the groups tend to have special names. Let's check them out.
The group on the far left is called the alkali metals. These elements explode when they come in contact with water, especially the ones towards the bottom of the group.
Next to the alkali metals are their cousins, the alkaline earth metals. They also explode when they meet water, especially if they've already reacted with oxygen.
Way over on the other side, the elements in the far right column are called noble gases.
Roll, Britannia, Britannia, roll down wave.
They're very stable, so they don't change easily, and they don't usually combine with other elements.
Next to the noble gases are the halogens. Halogens are so reactive they don't exist by themselves in nature. Every time they come into contact with another element, they immediately react and combine with it. So they're not pure elements anymore. You'll only find pure halogens in the lab for a second.
Take chlorine, for example. It's a halogen, and by itself at room temperature, chlorine is a greenish gas. We know chlorine is used to keep swimming pools clean, but when was the last time you saw green gas floating around in the shallow end? By the time you find it, it's already combined with hydrogen and oxygen to keep everything fresh and clean.
It's probably also hanging around the dinner table, fending off the blahs as it combines with sodium to make sodium chloride, or table salt.
There's one exception to all these rules: hydrogen. The first element on the table is kind of a diva. It's located in the alkali metal group, even though it isn't an alkali metal. In fact, it doesn't behave like any other element, so it doesn't belong to any family on the table. Anytime you're considering a trend on the periodic table, remember that hydrogen might not play along.
Those are the basics of how the periodic table is set up.